So we do have one injection mold machine here, which is a little bit special. On the other machines down the other end, what we just looked at, they've got a drying system. In other words, the polymer is dried in a tumbler, in a dryer system. Then that is added into the actual injection mold hopper at the top here, and then injected in. This does not have a drying system. The drying system is in the barrel. In other words, it's an in-barrel drying system. And this is particularly useful for polymers that are sensitive to moisture. Okay, so we've got a product that does not sort of stand well, or a polymer that is not reactive with moisture. This is a really good machine for that. Okay, right, so let's go and have a look at the tool room. Now, we do design and make all of our tools in-house. You see some activities going on there, but we'll come back to that. Let's start this first process, which is CNC machining. Now, I might have to speak up a little bit because it's a little bit noisier in here. Hopefully you can hear me. Yeah. Right, in here, I need to be careful because there's a lot of heavy equipment and sort of parts going on. So we've got one CNC machine over here. This is dedicated to cutting steel. Mind your eyes. So you can see here, this is a steel. This is a tool that is being prepared. So this is basically what we're doing, rough machining. Rough machining, well, it's not finished machining, but basically what we're doing is getting a rough shape so it can go into the next process. Now the next process requires copper electrodes. And this machine is where all the copper electrodes are being made. I'm not going to open the door because that's an unsafe practice, but maybe we'll be able to see in there all of the sort of copper colour. That's basically where I'm machining those electrodes. So let's go and have a look where they're used. So you'll be able to see here, this is a typical copper electrode in this particular shape. Okay. So when we've done the CNC machining from the steel, that's basically going to get to about 80 to 90% of the shape itself. When we get to the final shape, or maybe 99% of the shape, we need something like this, where it basically comes down and it sparks out a very small amount of time, amount each time, to this very, very specific profile. Okay? So again, we can have a look at that in operation here. So if we look very, very carefully, you'll be able to see some sparks jumping between those two components. Now, what's happening here is an electric current is running through the two parts, and as the copper touches the steel, an electric current makes a short. In other words, it's shorting out, creating that spark. And this is commonly known as spark eroding, simply because it's creating that spark. We've got 3 of those machines. They're all running at the moment. Everyone's like crying out for their parts to be finished before Chinese New Year, so we're crazy busy on this particular area. Now again, on this particular part here, you can see a number of different impressions. I believe this is going to be going on to either injection molding or a silicone molding. But again, we've got a number of different impressions there. This is definitely a silicone molding tool, but again, same process when we're actually shaping the components out of the steel. Now, if you ever wondered why your steel tool costs a lot of money, well, there's a lot of material in a steel, but there's also a lot of processing. And one of the hand processing finishes is polishing. Now, if you want a mirror finish, that takes a lot of effort. And a lot of effort means a lot of time. A lot of time means a lot of labor. And this particular sort of lady here is an expert when it comes to getting mirror finish and polishing hand tools. And you see the fine detail on this. Absolutely brilliant. Okay. So again, got to be careful where we're walking around here because there's a lot of heavy equipment, a lot of cables running around the floor. Okay. So not everybody is allowed in here, only certain staff that are qualified. But you can see here, where we're talking about fine finishing, hand finishing, one of the technicians is looking at a particular component here, just doing a quick modification on the tool. See some fine work. Over the back here, we're actually doing an assembly of a tool. So this is a relatively small tool compared to some of the ones we saw. So this will happily fit on a 90-ton machine, one of the ones in the dust-free environment that we saw. So again, we're doing a final fit of the assembled sort of tool itself. You can see some of the components on the tool itself. We've got all of these different parts. Down this side, we've got a number of pins. Okay, now these pins are purely, they eject. In other words, they push forward and push the actual plastic part out of the tool after it's been molded. Okay, commonly known as ejector pins. Right, through the back here, once your tool has been produced, it will come into storage. Okay, and each of the storage racks has got a number and a location. Each of those locations are sorry about the noise, we're in a workshop, let's face it. So each of the tools is actually located on the rack here. So if we need to find a certain project code, we'll have a look at the board, see the location, we'll be able to take that tool out. Now, as we're using the tool will be run, your parts will be produced. Before it's stored, we'll do some general maintenance just to make sure that it's all oiled up. There's no parts, no sort of leftover plastic parts inside sort of the tool itself. So it's ready for the next time it's being used. Now you'll be able to see some different things on here. I often get asked, what's this part here? Well, why isn't it on this one? Well, there are two different systems. This is what we call a hot runner. So this is basically heating up the runner system. We looked at the runner system earlier where we had those 4 keys. We had the sprue and the runner system. Well, this doesn't have that because it's all kept at a fluid temperature, and that saves temperature, the material. In other words, brings the cost down on the actual individual parts. However, the cost of the tooling goes up. So it's a balance with respect to the quantity you need to produce from a part unit versus the cost of the tool. Okay? So this is why we've got this piece of electrics or electronics on some of the tools, not the others. This is what we call a cold runner system, which is exactly what we had to look at, where we've got the 4 parts branching off of that sprue system. Right, there's just one more area to have a look at through where the tooling is assembled. This is where a lot of the smaller tools are done on the bench. Now, sometimes they're a little bit too heavy to go on the bench. So they're basically done on the floor or a lower bench, let's say. Let's see if we've got any action going on this end. So generally this is where some of the larger tools are assembled. And you can see sort of some of those over here. Got some sort of relatively large and very, very heavy tools that are being made. There was one in here last week, which is a little bit taller than I am. I'm 186 or 6'2", whichever language you speak. So again, a huge tool. Okay, so that's a quick wrap down of the plastic injection mold place. So I hope that was interesting.